This example is for MGF 1106 in Chapter 2 when we are dealing with unions and intersections and complements of sets. When you have a set statement that has parentheses, we should complete the operation within the parentheses first. So when we are looking at this problem, we need to first take the union of A complement and C. So to find A complement, or the complement of A, that will be all those elements that are not in A but still in the universal set. So we see set A, the elements in set A right here. So the complement of that would be the elements B, E, H, J, and K. So we have to unite that set with C. Now remember, union means take all the elements of one set along with all the elements of the other set. You're joining them together. So the complement of A united with C, since it's a union problem, it will be all these elements that are in the complement of A together with all these elements that are in C. It's just we don't list an element twice if it's in both. So we're joining them together. So we have to include A, B, E, F, H, I, J, K. Those are the elements that are either in C or not in A. Then before we do the union in the middle, we have to do the intersection that's in parentheses to the right. So it'd be A intersection B. Intersection means what they have in common. So looking back up here at A and B, C's in both, D, F, and G. Those are the elements that are in both sets. Now we can take the union. So we're going to take the union of the first set and the union with the union of the second set. So I'll write that out. So it's the set containing the elements A, B, E, F, H, I, J, K. Then we have to unite that with the intersection, which was the set containing the elements C, D, F, and G. So the final answer to the problem, which again was the complement of A united with C, united with the intersection of A and B, will be the union of the two sets that we have in the line above. And when we take the union, we join them together. So we take all the elements that are in one set or in the other. So A and B are in the first set statement. C and D are in the second set statement. E is in the first one. F is in both. G is in the second one. H, I, J, K, because they're all in the first set statement. So we have A, B, C, D, E, F, G, H, I, J, K. So our answer, if you look back at the original sets that they gave you, our answer is the universal set. We have all the elements that are in the universal set. So we could write it in roster form and list all the elements, or just put U. And that is an example in Chapter 2 of MGF 1106.